All right.
Okay.
Okay. All right, good afternoon, students, and welcome to our chemistry class today. I still remain your chemistry tutor, Ms. Esther. So our topic this afternoon is on acid, base, and salts. Okay, and as usual, I have my slides to share with you. So if you have any question, feel free to drop it at the comment section. Okay. Okay. So I have my topic. So the topic this afternoon is on acid, base, and salt. But we're going to begin with the first part, which is what acid. Now, I think right from when majority of us were little, when we come across the word acid, when we hear someone calling an acid, the first thing that will come into our mind is that an acid is this harmful chemical that no one is expected to go close to it. But trust me, this afternoon, I'm going to explain to you that some acids are not harmful, while some acids are actually what? Harmful. Now, acids are chemical substances that are used literally around us. In our body system, we have acid in the food we take and oil in the food we consume. These food substances contain what? Acids. Okay. Now, here I have the definition of an acid. Okay, as provided by 3 scientists. Now, the first one is by Arrhenius. Okay, now Swabant Arrhenius, okay, gave the following definition of an acid. Now, he defined an acid as a substance that, when dissolves in water, produces hydrogen ion as the only positively charged ion. Now, examples of acid, we have hydrochloric acid, we have trioxynitrate 5 acid, that is HNO3. We also have tetraoxosulfate 6 acid, which is H2SO4. And then we also have ethanoic acid, that is CH3COOH. So these are examples of what? Of acid. So he gave the definition that an acid is a substance that, when dissolved in water, we produce hydrogen ion as the only positively charged word, ion. Now, we also have another definition as proposed by 2 scientists. A combination of their names gave us Bronsted-Lowry. Now, these 2 scientists, that is Nicholas Bronsted and Newton Lewis, okay, they gave the definition of an acid as follows: that an acid is a proton donor. Okay, now the proton is a hydrogen with a plus charge on it. So an acid is a proton donor, that is from a conjugate to form what? A conjugate word, base. Okay, so an acid will donate a proton. So here I have a reaction, okay, by ethanoic acid. So a reaction, so the equation you have there is actually a reaction by ethanoic acid. First, as you can see, a proton is generated when it dissolves, and then a conjugate base, that is ethanoic, yes, acetic acid is what is formed. Now, so that is his own concept, or that is their own concept of an acid. Now, I also have another one, that is Gilbert Lewis. He also gave a definition of an acid as an electron pair acceptor. Okay, so an acid is that substance that will what? Accept an electron. So examples are all cations like hydrogen ion, potassium ion, iron 2 ion, iron 3 ion electron. Like boron gave his own different a proton donor. And Arrhenius defines an acid as water. We produce hydrogen ion. Okay, so here I have a table of the organic acid. So now for the organic acid, please. So for the organic acid, okay, now they are acids that are obtained from plants and animals. Okay, so here I have a table of what containing list of what organic acid and also their source. So the organic acid, they are actually acids that are gotten from natural sources. That is from either plants or from animals. So the first one is ethanoic acid. Now it is gotten from vinegar. Okay. Now we also have the lactic acid, which is gotten from milk. We also have the ascorbic acid, which is gotten from orange. We also have the citric acid, which is gotten from lemon and also unripe orange. Now we also have what we call the tannic acid, which is gotten from tea, and then the fatty acid, which is gotten from fats and oil. And then we have the methanoic acid that can also be obtained from ants. And then we also have trioxocarbonate 4 acid that is gotten from fizzy drink. So these are actually some examples of organic acid. Okay, so I also have, okay, so when we talk about fizzy drink, we're actually talking about carbonic drink, okay, or carbonated drink, like your Coca-Cola, like your Pepsi, etc. All these are examples of fizzy drinks. Now let's look at the mineral acid. Now the mineral, also known as the inorganic acid, they are actually gotten from, or they are prepared from what? They are prepared by humans in the lab or in the chemical industries. So the mineral or the inorganic acid are not gotten, they are not gotten from natural sources. Rather, they are prepared by what? By humans, or they are man-made, also known as what? Man-made acids. Now the first one is hydrochloric acid. We also have tetraoxosulfate 6 acid. We also have trioxonitrate 5 acid, and then we also have tetraoxophosphate 5 acid. All these are examples of what? Of inorganic acid. Now let's look at the inorganic acid. Okay, yes. Now, acid actually can also be further be grouped into strong and weak. So going back to the inorganic acid, okay. Oh yes, so acid in general, not just the inorganic acid. So acid in general can be grouped or categorized into the strong acid and also into the weak acid. Now for the strong acid, okay, now the strong acid is an acid that ionizes or dissociates completely in water. So when we talk about ionization or dissociation, it means that the ability of that acid to separate into its component ions when dissolved in water. Okay, so that is what the ionization or the dissociation means. So when the acid dissociates or ionizes in water, okay, it actually ionizes completely. So we have different ionization of KCl, trioxonitrate 5, and also tetraoxosulfate 6. So looking at the equations, the equation is actually showing the different ionization of these 3 mineral acids. Now we also have the weak acid. Now the weak acid is an acid that ionizes partially in water to release the hydrogen ion. Okay, so example is the ethanoic acid, okay, which happens to be a weak acid. And not just a weak acid, it is also an organic acid. So as you can see, despite having 4 hydrogens, it is only one that is actually ionized. Okay, so one it is only a single hydrogen that is ionized when dissolved in water. Okay, and one thing you need to know is that all organic acids are weak acids. They are not strong word acids. And ethanoic acid is also what? An organic acid. All right, so still on the classification of an acid. So here we have the concentrated, okay, and also the diluted word acid, okay? So for the concentrated acid, it is obtained when little or no amount of water has been added to a large volume of an acid. So a concentrated acid is that acid that contains little or no amount of water, or the proportion of acid is greater than the proportion of water in that acid. Now, we also have the diluted word acid. Now, by diluted means that a large quantity of water is added to it. So the diluted acid solution is obtained when little volume of acid has been added to large volume of water. So therefore, in the diluted acid, the proportion of water is greater than that of what? Than that of the acid. Okay, that is what it's all about. Okay, that is what the diluted acid is all about. And another thing you need to know is that both the strong and the weak acid can either be concentrated or they can either be diluted, depending on the amount of water added to them or added to to the acid sample. All right. Okay, so here I have a table. Okay, I have a table containing the basicity of an acid. I know you are familiar with certain acid in science. A common one is HCl. Another one is tetraoxosulfate 6. Now, the basicity of an acid basically means the number of replaceable hydrogen in one molecule of the acid. Okay. Now, how do we obtain the number of replaceable hydrogen? That can actually be obtained from the number of hydrogen that are being ionized, okay, or hydrogen ions that are formed after a particular acid undergoing dissociation or ionization. Don't forget that ethanoic acid, despite having 4 hydrogens, it is only one that is being ionized. Okay, so don't forget that. Now, here I have the first acid, which is HCl. Okay, now the ions present are hydrogen ion and then chloride ion. So therefore, as you can see, when HCl dissociates, it is only one hydrogen ion that is produced. So therefore, the basicity of HCl is 1. And we can also call that a monobasic acid. Now, going to the next one, which is trioxynitrate 5. Okay, when it ionizes, it produces 1 hydrogen ion, okay, and then the nitrate ion. So therefore, the basicity of trioxynitrate 5 is 1. So therefore, trioxynitrate 5 is monobasic. Now we also have the tetraoxosulfate 6. Now the tetraoxosulfate 6, as you can see, okay, it contains 2 ions of hydrogen when it undergoes ionization. Okay, so therefore, the basicity of tetraoxosulfate 6 is 2, and therefore H2SO4 is dibasic. Okay, it is dibasic. All right, so we also have the phosphate phosphate acid. Okay, now as you can see, when it undergoes ionization, that is the tetraoxophosphate 5 acid. Okay, when it undergoes ionization, okay, it produces 3 hydrogen ions. Okay, it produces 3 hydrogen ions and then the phosphate ion. So therefore, phosphate acid is tribasic, and as such, the basicity is 3. All right. So here I have preparations of acid. Okay. So the first one, how do we prepare acid in the lab? So the first one is by dissolving an acid anhydride in water. Okay. So what is an acid anhydride? Now, an acid anhydride is an oxide of a non-metal that forms an acid when it dissolves in water. Okay. Now, non-metals in the periodic table are actually what? Elements from like those in group 4, they exhibit the non-metallic properties. They are non-metals. Those in the group 4 are also considered non-metals. They are also what they're categorized as the metalloid or the semi-metals in the periodic table. So oxide of elements such as carbon, sulfate, and sulfur, nitrogen, they are what? Acid anhydride. Okay. So as you can see, when carbon 4 oxide is dissolved in water, it produces what? A carbonic acid, which is known as trioxocarbonate 4 acid. And trioxocarbonate 4 acid happens to be a weak acid. It is not a strong acid. Now, another one is this. You can also prepare an acid by combining the acid with constituent elements. So first one, as you can see, there you have heating hydrogen in chlorine, okay, in the presence of activated charcoal as a catalyst, okay, will produce hydrochloric acid. So when you combine hydrogen gas and chlorine gas in the lab, in the presence of a catalyst such as charcoal, activated charcoal, that will result to the formation of hydrochloric acid. Okay. All right, so we also have the strong acid. So another method is by using a strong acid to displace a weak acid or a volatile acid in a solution. Okay. The tetragosulfate 6, okay, and then you also have the sodium nitrate. Okay, now sodium nitrate. As you can see, using a strong acid like tetragosulfate 6 to displace a weak acid or a volatile acid from its source. Okay, now as you can see, okay, so tetragosulfate 6 is reacting with sodium nitrate. Okay, so the sodium, the hydrogen, okay, to form a salt, okay, and the hydrogen will now combine with the nitrate ion to form trioxonitrate 5. Now, the reason why sodium can easily displace hydrogen to form sodium and sulfate is because going back to what we call the activation series, the activation series of metals, okay, or the electrochemical series, as you can see, okay, yeah. So sodium, okay, is above hydrogen in that series, okay, of metals. So therefore, since sodium being of let's say hierarchy than hydrogen, sodium can easily displace hydrogen to form what? All right, so here I have properties of an acid. So I have physical properties of an acid. Now the first one is that the acid has sour taste. Common example is lemon. Try dipping a lemon or a drop of the lemon juice on your tongue. You will discover that the taste of a lemon juice is actually sour. So, and also, another thing you need to know is that an acid can actually turn a blue litmus paper red. Okay, so a litmus paper is actually an indicator used to test the presence of an acid or a base in a solution. And also concentrated acid are corrosive. They can damage the skin, yes. So they are harmful and they are toxic to the skin, okay? And that is why any chemical substance containing an acid, there is always a caution sign on how to handle such chemical. Now, note that always add acid to water and not water to acid in order to avoid splashing of the acid vapor on the face and also the body. Now, the reason why you need to add an acid to a water, okay, instead of water to the acid is because acid reacts vigorously with water. So if care is not taken when handling an acid, okay, it can easily splash on the skin and also damage the face or the body. So care must be taken while handling it. So here I have some chemical properties of an acid. Okay. Now the first one is this. An acid reacts with metals, okay? So an acid will react with a metal to produce hydrogen gas. So acid reacts with some metals to produce hydrogen gas. So an equation is there, a reaction between hydrochloric acid and zinc metal will produce zinc chloride, which is a salt, and then hydrogen gas. So when an acid reacts with metal, a salt is formed, and also hydrogen gas is liberated. Now another reaction is with bases. So an acid reacts with bases, okay? Acid reacts with bases to form salt and water only. And that reaction is known as neutralization reaction. So the reaction between an acid and a base is known as neutralization reaction. And a salt is formed and water is also formed in the process. So a reaction between tetrahydrosulfate 6, okay, and potassium hydroxide will result to the formation of potassium sulfate or potassium tetrahydrosulfate 6, and then water is also produced in the process. Now I also have, okay, I also have a reaction between an acid and triazocarbonate 4 salts. So when an acid reacts with triazocarbonate 4 salts, okay, carbon 4 oxide is produced in the process. Okay, so here is a reaction between hydrochloric acid and sodium triazocarbonate 4 salts. Okay, so as you can see, a salt is produced, which is sodium chloride, water is produced, and then carbon 4 oxide is liberated. So a reaction between an acid and a carbonate salt will result to the liberation of a gas, which is known as carbon 4 oxide or carbon dioxide. Okay, so let me run it again. So chemical properties of an acid are, first is a reaction with metals to produce salt and hydrogen gas. Okay, another one is a reaction with base, which is known as neutralization reaction, to produce salt and water. And then another reaction is between an acid and the triazocarbonate 4 salt to produce carbon 4 oxide. Okay, salt and also water are liberated in the process. So here I have a table containing the uses of certain acids. Now the first one is hydrochloric acid. Now it is used for removing rust and also for making chemicals in the lab. Okay, there are certain analysis like the volumetric analysis in the lab and also qualitative analysis that are carried out using the hydrochloric acid. Now we also have tetrahydrosulfate 6 acid. Now in my last class with you, I mentioned tetrahydrosulfate 6 acid as a heavy chemical, meaning that it is produced in large quantity. So this tetrahydrosulfate 6 acid, okay, is actually used in the manufacturing of certain chemicals in the industry. So it is also used as a drying agent and also dehydrating agent for making chemicals. And it is also used as an electrolyte in lead acid accumulators, that is a car battery. Okay, so that chemical substance that helps to generate electricity in the car battery is tetrahydrosulfate 6 acid. Now we also have trioxyl nitrate 5 acid. It is used for making fertilizers and also explosives. Now we also have ethanoic acid. It is used for preserving food, okay, and also for dyeing textiles. We also have citric acid for making fruit juice. We also have fatty acid for making soaps and also for cooking. So these are some of the uses of an acid. Now here we have the base, okay? So I also have definitions proposed by these three scientists that also gave the definition of an acid, okay? So the first one is by Arrhenius. So he defined a base as a substance that dissolves in water to produce hydroxyl ion as the only negatively charged ion. So what you have there is sodium hydroxide dissociated or dissolving in water to produce sodium ion and then hydroxyl ion. So Bronsted-Lowry definition of a base goes like this. A base is a substance that accepts proton or hydrogen ion from another substance. So when a base accepts a hydrogen ion, it forms a conjugate acid. Okay, so example, we have water and also ammonia. So we also have a reaction between water and ammonia. Okay, so as you can see, we said the acid is a proton donor. Okay, and then the base is a proton acceptor. Okay, as proposed by Bronsted-Lowry. So when the water dissolves or dissociates, it will produce hydrogen ion, okay, and then hydroxyl ion. So as you can see, the hydrogen ion we combine with the base to form a conjugate acid. And then the hydroxyl ion will now be the conjugate base in the reaction. Okay, so we also have another reaction between trioxyl nitrate 5 and water, forming a conjugate acid that is oxonium ion, okay? And then we also have the nitrate ion, which is the conjugate base in the reaction. So we also have another definition by Lewis, okay? So Lewis gave his definition of a base as a substance, a molecule and ion that donates a pair of electrons. So in his definition of an acid, he defines an acid as a substance that will accept an electron. So examples of substances that can donate electrons, we have the hydroxy ion, the fluoride ion, we have ammonia, and then we also have this sulfate ion. So examples of bases. So what we need to know is that the basis of the pH, that is the potential of hydrogen or the degree of alkalinity of bases, okay, using the pH scale, okay, ranges from above 7, because 7 is a neutral pH. So from, let's say, 7.5 upwards down to 14, that is the pH for most basic substances. Now, bases are usually metal hydroxide. That is hydroxide of sodium, hydroxide of potassium, hydroxide of calcium, okay, and also hydroxide of aluminium. So elements in group 1, 2, and 3, okay, can easily form metallic hydroxide. And another thing you need to know is that a soluble hydroxide is called an alkali. So an alkali, therefore, is a base that is soluble in water. Okay, so we also have the hydroxide of sodium, potassium, and also the that's of calcium and okay, they are examples of alkali. So another thing you need to know is that metal oxide. Okay, so bases are usually metal oxide. So we have oxide of sodium, sodium oxide, calcium oxide, magnesium oxide. All are basic substances. And also bases are also metallic triiosocarbonate 4. So sodium triiosocarbonate 4, potassium triiosocarbonate 4 are also basic in nature. Now here I also have classification of what bases. So we have the strong and the weak bases, just like we have what the strong acid. Now for the strong ones, they are bases or alkali that dissolve completely in aqueous solution, okay, to produce hydroxyl ion, okay. While the weak ones, okay, they will ionize partially in aqueous solution to produce hydroxyl ion, okay. Now, as you can see, all alkalis are what? All alkalis, okay, alkalis, sorry, are strong bases, but not all strong bases are what? Alkalis. So if you look at the concept of an alkali, that basically what? Oxide or hydroxide of metals of group 1, and then some in what? Group 2. So here we have physical properties of bases. Now bases have bitter taste. Try one substance at home that contains a base, or that is an example of a basic substance, is your detergent. Okay, yes. And also detergent, and also the soap, bathing soap or your laundry soap. So these are actually what basic substances. Okay, so they have bitter taste and they are soapy to touch. So when you touch a detergent or a soap, it is actually what's liquid. And bases turn red litmus paper to blue. And concentrated bases or alkalis, okay, are corrosive to the skin. So here I have some chemical properties of bases. So one is reaction with an acid. So the reaction between a base and an acid is known as the neutralization reaction. So bases react with acid to produce salt and water only, okay? And then we also have a reaction with ammonium salt. So when a base reacts with ammonium salt, a gas is liberated, and that gas is ammonia gas. So here I have a reaction between calcium hydroxide and ammonium chloride. Okay, as you can see, calcium chloride is produced, which happens salt. Water is also produced, and ammonia gas, that which is HNO3, is also what produced. So going back to the reaction of an acid, okay, when an acid reacts with metals, a gas is produced, and that gas is hydrogen gas. When an acid reacts with triazole carbonate 4, okay, salt, carbon dioxide or carbon dioxide is what? Liberated. And when the base reacts with ammonium salt, a gas is also what? Liberated. And that gas happens to be what? The ammonia gas. So here I have uses of what? Base or what? Alkalis. So the first one is sodium hydroxide. It is used for making soaps, for making salts, okay, for making using the textile, and also for paper making, and also for refining of petroleum. Now, calcium hydroxide is used for making cement, whitewash, bleaching powder, and also for reducing what? Soil acidity. Okay, so in agriculture, they carry out what we call liming. Okay, yes. So that liming involves the application of what? Calcium hydroxide to reduce the acidic nature of the soil. Now we also for softening hard water. Now we also have magnesium hydroxide, which is used as an antacid or laxative, and also for the antacid is used to reduce gastric acid, okay, and also it's also used for making toothpaste. Now ammonium hydroxide for making fertilizers, rayon, plastics, dyes, and also as an analytical reagent in the lab. So we also have for making basin soaps. So all these are some of the uses of of an acid, sorry, of a base, and also of an alkali in around us or in our environment. So here I want us to look at some concepts when it comes to acid, bases, and salts. Now I mentioned pH or base if someone is acid. Now the pH of acid from 0 to 6.5, okay, that can also, let's say 6.5 or 6.4 is the pH range for most acidic substances. Now, what is this pH all about? Now, the pH, which is also known as the power of hydrogen ion, it is a measure of the acidity or the alkalinity of a substance. Okay. Now, we also have another definition. We can also put it this way, as a measure of the hydrogen ion concentration present in a solution. And it can also be expressed as a negative logarithm to base 10 of hydrogen ions in moles per dm cube present in a solution of a substance. So, and pH is measured using the pH meter. Okay, so it is always good to monitor the pH of a substance and also the pH of certain chemicals in the body. Okay, yes, there are certain level of pH that are comfortable or good for the body, but it is always good to monitor the pH. And also the drinking water we take, okay, the pH ought to be monitored. So now we have pH, okay, is given as negative logarithm to base 10, okay, of hydrogen ion. So it means the pH, okay, where you have the hydrogen ion will give you that of what? That of the hydroxyl ion, okay? So now in an ionic equilibrium of water, okay? So the ionic equilibrium of water is the product of the concentration of the hydrogen ion and the hydroxyl ion. Because when water dissociates, it produces hydrogen ion and also hydroxyl ion. Okay, so as a product of of the concentration of the two products will give us minus 14 moles per dm cube. Okay, yes. Now the dm cube, as you can see, is actually squared, and so therefore as negative of 10⁷. So therefore, pH plus pOH will also give us 14. So here is a typical the picture of a pH scale. Okay, so as you can see, from 6 down to 0 is an increase in acid, and also from 8 down to 14, we have the alkalis and also the base increasing. So here we have some substances, okay, and also their pH values. All right. So I think I'm going to draw the curtain here. When next we meet, I will get some problems for us to solve on the pH of certain chemical substances. Okay. So going through the substances, we have the stomach. Okay. The pH is 1. Hydrochloric acid, the pH is also 0. For lemon, the pH is 2. Vinegar is 3. Wine is 4. Coffee is 5. Milk is 6. Down to to drink, with a pH of 14. So my dear students, I'm going to draw the curtain here. If you have